But you can think of it as like a bank account. There are systems where you can pump a lot of water out of the ground, but there's also a lot that goes in from the rainfall or coming in from rivers or lakes. And that can be fine. But there are ways to capture water on the surface and just give it a little bit more time to infiltrate, then you can end up getting more water into the ground. But you need to be careful about a quality issue with that, because if you pump a ton of not really clean water directly into your groundwater, then you can have groundwater contamination issues, which are very challenging to solve. There are huge energy and economic impacts. And then, of course, there's the point where the water passes some threshold where it just doesn't make sense or it's not possible to access it anymore.
Welcome to Liquid Assets. I'm your host, Ravi Karani. Liquid Assets is a podcast where we talk about the intersection of business, policy, and technology, all as it looks at water.
Hi, my name is Tess Russo. I am a senior program officer at the Bill and Melinda Gates Foundation on our agricultural development team. And I work on our climate adaptive systems and agricultural water management portfolio.
And Tess, without further ado, I'm just going to go ahead and hand you the mic. If you can kind of introduce yourself, tell us about where you're at right now, what you're up to.
Yeah, sure. Hi, thanks again for having me, Ravi. I'm at the Gates Foundation. I'm a senior program officer on our agricultural development team. My background, though, is in hydrology. I have a PhD in hydrology from an earth science department, UC Santa Cruz, and have done most of my work since then through my postdoc and onward in agricultural water management. What we're doing at the foundation around water. I also spent a couple of years at a small invention company. Before the foundation, I was a professor at Penn State for a couple of years and then moved to this invention company where we had some programming around product development for irrigation in sub-Saharan Africa and South and Southeast Asia. So aiming to support smallholder farmers, small-scale producers with irrigation and water access equipment.
Got it. Cool. Let's go ahead and unpack that a little bit. So the first thing I want to kind of touch on is your background in hydrology, right? So for the people out there that don't know what hydrology is, can you give us kind of a layperson's definition of what exactly is hydrology?
Yeah, sure. Sorry, I should. We have a problem at the Gates Foundation of using too many acronyms. And so I also need to now be careful about which words I'm using. Hydrology is basically just water science. So the study of water. And what I did in hydrology was looking at the hydrologic system and the way that humans and climate change are impacting that hydrologic system. So how water is moving through that water cycle. So like one example that we looked at was downstream of a reservoir that was used for providing water to the city of San Francisco. They were doing some controlled flooding experiments. And so we were looking at ways to optimize the release of water so that it would have the greatest environmental benefit, ecosystem benefit, but use the least amount of water so that we weren't, losing too much water for the city, but having these other benefits.
Yeah. And I remember when we kind of had our first intro call, you had really talked about combining, and what you really loved about this is combining the physics, combining chemistry, combining numerical modeling. Feel like you're able to kind of put this full stack approach using hydrology actually out in the field. Can you kind of two things? One, can you zoom out really quick? And you obviously focused on the hydrology being the study of water, focusing kind of on the hydroelectric system and how that kind of works. But what other verticals in hydrology are there? And then secondarily, kind of, can you guide us through the field work that you've done? Because I think that's super cool work that you've actually done in your career.
Yeah. So within hydrology, there may be a sort of taxonomy or typology of groups, but I would group it into sort of three main areas to begin with. One being surface water, the water that you see in lakes and rivers, water that we're storing above ground, groundwater. So then everything that's underground, all the water that we don't see, that when you drill a well, you access, or if you dig a pit deep enough, you might hit groundwater. So those are two. And then there's certainly the interaction between those two is a very active area in hydrology. So how you get water from the surface down into that groundwater system, and then how it comes back out in certain places. And then the sort of atmospheric water, which falls more into atmospheric sciences, I would say, but there are a lot of hydrologists who study precipitation patterns and the connection between that and the rest of the hydrologic system. So sort of things that are happening in the air, things on the land, and then things underground, I would say.
Got it.
And
That's such a beautiful explanation. Yeah. Sorry, go ahead.
no, I'm just trying to make it, simple, sort of. It's something that you could imagine or see. With I think groundwater being the trickiest of those three for most people to like really wrap their head around what that is. And I think I taught one of my classes at Penn State that I taught was a introduction to hydrology course, and we talked about groundwater. And most of the students, when you ask, what is groundwater? What's groundwater look like? They think it's this a big underground lake, or something where if you burrowed down into the ground, you could like go swimming in it or scuba diving. And that's not what most of groundwater is. Most of groundwater is just packed in between the sand grains or soil grains or whatever the rock is that it's in. And it's not something you could, swim around in or have a fish swimming around in. There are some caves that are part of the groundwater system where there are larger bodies, but it's somewhat harder to visualize true groundwater.
Yeah. Yeah, totally.
Yes.
That's such an amazing explanation of hydrology. I think that would actually work amazingly well. And for all of those of you out there, if you want to listen to Liquid Assets, you can find us at liquidassets.cc or anywhere else you get your podcasts or on YouTube today.